Hello everybody, today we will be dealing with the topic vector algebra. Now, what are vectors? Vectors are physical quantities which have both magnitude and direction. Suppose consider a vector a bar, then the direction of a bar is where the arrow is pointing and the magnitude is given by the length of the vector. So, the magnitude is denoted by mod a bar and it is the length of the vector. Now, types of vectors. The very important types of vectors are zero and null vector. The speciality of this type of vector is that it has magnitude 0 and it is denoted by 0 vector. Remember one thing about zero and null vector, that they have not defined direction. People think they have infinite direction, but which is not true. Now, unit vector. Unit vectors have magnitude 1 and are denoted by a cap, n cap, I cap, so on. Any vector can be denoted in terms of unit vector as, for example, consider vector a bar with magnitude mod a bar, then it can be written in terms of unit vector along its direction a cap as a bar is equal to magnitude of a bar into a cap. Now, we'll turn our attention to algebra of vectors. Vector parallelogram law of vector addition. If there are two vectors a bar and b bar, then their addition c bar will turn out to the diagonal of the parallelogram formed by the vectors a bar and b bar. Now, linear combination of vectors. If r bar is equal to x a bar plus y b bar plus z c bar and so on so forth, then where all x y z are non-zero, then r bar is linear combination of a bar, b bar and c bar. Now, for linearity condition for collinear vectors. If a bar and b bar are two collinear vectors, then a bar will turn out to m times b bar. Now, condition for coplanarity of three vectors. If r bar is coplanar with a bar and b bar, then r bar will turn out to be x a bar plus y b bar, where x and y are any real numbers and a bar and b bar must not be collinear. Now you may ask me why I am not considering for two vectors coplanarity condition, because any two given vectors are always going to be coplanar. Take an example, r bar is equal to x I cap plus y j cap. So r bar will be coplanar with I cap and j cap, that is in the xy plane, and AB bar is given by B bar minus A bar, where B bar denotes the point B and A bar denotes point A. Now, section formula. Section formula for internal division will turn out to be C bar is equal to M A bar plus N B bar upon M plus N, where there are 2 points A, B and C divides the line AB in the ratio n is to m. Then C bar is given by this. M and n are any real numbers obviously. For external division, C bar will turn out to be M A bar minus N B bar upon M minus N. He is dividing externally the ratio n is to m. Remember here CA by CB is n is to m. We'll turn our attention to multiplication of vectors. There are two types of multiplication. One is scalar or dot product and the other is vector or cross product. First of all, scalar or dot product. If there are two vectors a bar, b bar and the angle between them is theta, then the dot product a bar dot b bar is given by magnitude of A into magnitude of B into cos theta, where theta is the angle between those two vectors. Now the properties of vector scalar dot product. A bar dot B bar is equal to B bar dot A bar, that is dot product is commutative. A bar dot B bar plus C bar is equal to A bar dot B bar plus A bar dot C bar. It implies that the scalar dot product is distributive. A bar dot B bar is equal to 0. It implies what? Cos theta is equal to 0, which implies what? Theta is 90 degrees. So A bar and B bar are perpendicular vectors. Now A bar dot A bar, in this case the theta will turn out to be 0. So cos theta is 1. So it will turn out to magnitude of A the square. If A bar dot B bar is less than 0, then the angle between them will turn out to obtuse. Let's check how. A bar dot B bar is equal to magnitude of A into magnitude of B into cos theta. But magnitude of A and magnitude of B are positive integers. Sorry, not integers but positive values. So if this whole quantity is less than 0, which implies cos theta is less than 0. So theta will turn out to obtuse. And vice versa, if dot product is greater than 0, that is cos theta will turn out to be greater than 0. So theta will turn out to acute. Now we will turn our attention to vector or cross product. If there are two vectors A bar and B bar, then their cross product is given by A bar mod of A bar times mod of B bar times sin theta times n cap, where n cap is a vector perpendicular to the plane of A bar and B bar. Now we will be dealing with the properties of vector or cross product. So if first of all, vector or cross product is not commutative, that is A bar cross B bar will not be equal to B bar cross A bar, but it turns out to be minus times B bar cross A bar. And second, vector cross product is distributive, that is A bar cross B bar plus C bar will turn out to A bar cross B bar plus A bar cross C bar. Now we turn our attention to scalar triple product. If there are three vectors A bar, B bar and C bar, then the scalar triple product is given by A bar cross B bar dot C bar. It is said scalar triple product because it will be an vector. It is denoted by box of A bar, B bar, C bar, that is determinant A1, A2, A3, B1, B2, B3, C1, C2, C3, where A1, A2, A3, B1, B2, B3, C1, C2, C3 are their I, J and K components.